This video is for lesson 11.3. So today we are going to be working with the coordinate planes again, and we are going to be finding distance between points. So if you have not already done the Spark Your Learning, go ahead and try that problem here. It's finding the shortest distance from the library to the coffee shop. So go ahead and try that and then come back and see how I thought about it. So I read that Nestor is bicycling around the city and the grid shows where everything is. So it's important to note that every square represents 200 meters. So when we're counting, here's 200, 400, 600, 800, 1,000 meters. So every time we complete a square, that's 2,000, 2,000. If I choose to go the other way, it's still, sorry, not 2,000, 200, 200, 200, 200. So every square, every time I go from a corner to a corner, that's 200 meters. Nestor wants to ride from the library to the coffee shop. So we want to go library to coffee shop. And he has to stay on the road. So the roads are the grid. So obviously this would be the shortest path, but then he might be driving through people's yards and things like that. They probably won't like that. So we need to find the shortest route staying on the road that he can take. So I want to go in straight paths to get there. So I'm going to go straight south and line up on the road that's the coffee shop. And then if he makes a turn left, he can get to the coffee shop. So that is 200, 400, 600, 800, 1,000. So if he goes 1,000 south and then 200, 400, 600 west, that's one way. So I'm going to see if there's any other ways. So 1,600 is what I'm thinking is the shortest. Let's see if there's another way that could be shorter. So let's go west first. So I'm going to grab a different color. So I'm going to use blue here. So he's going to go, this time he's west 2, 4, 600. And then we're on the road to the coffee shop. So now he's going to go down. So 2, 4, 6, 8, 10. So if he goes that way, so it's looking like the red and the blue routes are exactly the same. They just are, one goes down first, one goes over first, and then they flip-flop and do the opposite. They're both 1,600. So let's see if there's any other way so we can get there shorter. So let's see. So we're thinking 1,000. Whoops, I didn't write my 600. So we're thinking 1,600 is the shortest. Let's just double check. So here's 2, 4, 6, 8, 10, 11, 12, 13. So if he kind of zigzags. Oh, I did not count by twos though. Let me try that again. 2, 4, 6, 8, 10, 12, 14, 16. Still the same. So we still have that. Let's try another way. So it's looking like as long as I'm using these straight lines, it's going to equal 1,600. So I'm going to go over 2. So 2, 4, 6, 8, 10, 12, 14, 16. When I'm using the same path, so either way, look, I had to go over. So here's 2, 4, over another one, 6. I just did it at different times. So when I'm using these straight lines, if I made it longer, that would mean I'd have to go like around. So if I went 2, 4, 6, 8, 10, 12, 14, 16. If I went to the post office, then there's already 16. And then to the coffee shop, 18, 20, 22, 24, 26, 28. So if I go around, that is making it much longer. But as long as I'm going to the left 3 units, and then we go down 2, 4, 6, 8, 10. So there was 5 units down. So every time I go over 3, down 5, and in any combination of that, My shortest distance to get from library to coffee shop is 1,600 meters. So let's try, so before we try number one here, let's talk about what our goals are for today. So we want to find the distance between 2 points on a coordinate graph. So today they'll either have the same X or they'll have the same Y coordinate, and we want to find their distance. So that right there will give you a 3. You can find the distance between the 2 coordinates. You have accomplished what we need to today. We're also going to do a little bit extra today. If you can find the distance and reflect a point, we'll talk about what that means in just a second, but think mirror reflection. So if you can find the distance and reflect, you're a 4 today. If you can just find the distance, which is perfect, and what we want is a 3. If you can graph an ordered pair, that's a 2. In any quadrant. And if you can just do it in the first one that's positive, positive, that's a 1. So our goal here is to be able to graph them and find the distance here. So our first task tells us that a point on a coordinate plane can be reflected across an axis. So let's come up here and look at what is a reflection. So a reflection of a figure is a transformation of the figure that flips the figure across the line. So here we can see in this picture here is this mountain, and it got flipped over into this lake to see the reflection. It's kind of like a mirror. So it just does exactly the opposite. So we can see the tip was at the top. Now the tip is at the bottom, or the peak is at the top. Now it's at the bottom because it got flipped over the line. So it's like we took this picture, folded in half, and everything should line up there. So the reflection is located on the opposite side of the axis. So, right, if we have this axis, it went from here to here. So this one flipped across the x-axis. So we folded it on the x to get that reflection there. So this is the 4 information. So coming back here. So if you're trying to get a 4 today, this is the part I think will be the hardest for us, is understanding these reflections. But the distance that we find, that's our real focus today. So this is just some extra. So stay with me here. So first we want to graph the point 3, -2 on the grid. So let's go ahead and graph that here. So over 3 to the right, positive, down -2. So over 3, down 2. And this is all counting by ones. So here is our point right here. We want to reflect that over the y-axis. So if I fold this y in half, the point is going to flip over into this quadrant here somewhere. So I want you to think about that and see, where do you think this point would be if I flipped it over here? It's at over 3, down -2, and I want to flip it over here. So when I fold on the y-axis, they're in the same spot. So we're here, over 3, down 2. I want to go across this y-axis. That means it's got to be on the same line here. So if I fold that in half, so this is over, so we want this on the same line here. So this is over 1, 2, 3. So that means from 0, we've got to go the other way, 1, 2, 3. So I think if I reflect this, I will be -3, and then down to -2. So this was our reflected point. And let's write down our beginning point. So it was +3 and then -2. So, and we wanted to flip the y over the y. So I notice y is exactly the same. They were both -2. We had to keep that y both down the same amount. But we started at +3 and we ended at -3. So when we flip across the y-axis, it means we do the opposite of the x-axis. So if I fold these in half, we get the reflection here. So one thing it told you could do is you can get a paper, draw a grid. So it's a very pretty simple one. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we went over 3 down 2. So draw this on your paper, fold it in half on the y-axis, and poke your paper and see where does it end up. It should end up at -3, -2. So let's try a few more of those. So we are going to graph these points. So it asks you, if you want, you are welcome to fold a paper and do this. I'm going to look at it mathematically, but if you'd like to fold the paper and see where it falls, that's another great solution. So we're going to start and graph -5, 1. So -5, 1. So first, okay, so fold the paper on the y-axis and see what happens. And then we're going to fold it on the x-axis. So we're going to do both ways. So we go -5, +1. I put that in the wrong spot. So -5, 1, +1, -5, +1. Always go back and check. So here we're at -5, 1. So first we want to fold it on our y-axis. So it tells me, so if I fold this over, I want to keep it on my same straight across line here. So when I fold this over, it should be over in quadrant 1. So it was 1, 2, 3, 4, 5 away from 0. So I want to do the same thing going here. 1, 2, 3, 4, 5. So now it's at 5, 1. So when we reflect over the y, -5, 1 turns into 5, 1. So I notice, right, we want it to flip over y. So y stays the same. But when I flip over y, it makes x go opposite. Opposite of -5 is +5. So we flip that over. So now let's go down and flip it over the x-axis. So it was 1. We want to keep it on this line now. We're flipping it down. So it was 1 away from 0. So now 1 away from 0. It turned into -5, -1. So this time when we go across the x-axis, notice the x's stay the same, but then our y's are going to be opposite. So if you flip over y, y stays the same, x's are opposite. If you flip over x, x stays the same. So the one you flip over stays the same. The other one goes the opposite. So if this is confusing right now, it's okay. We're going to do more practice. Remember, this is the 4 today. This is the extra. So we're going to do the level 3 in just a minute and we'll be okay. So here let's graph 2, 4. So over 2, up 4. So here I'm going to make it a little bigger dot so we can see the difference here. So first we want to flip over y. So remember, y stays the same. The one we flip stays the same. So we want it on this line of 4. So y stays the same. And then we do the opposite of 2 is -2. So it should go over 2, up 4. So I can see, right? 2 and 2, when I fold that in half, they should touch and meet together. Oh, I just erased our answers. So opposite of x, y stays the same. So now we're going to flip across x. So now x is going to stay the same. So we were here at 2, 4. So we flipped over y. Now we're going to flip over x. So we want to go down now. So x is going to stay the same. We want it on the same line here. So over 2. And then the opposite of 4 is negative 4. So we want to go down 4 over 2, 1, 2, 3, 4 negative. So if I fold the x in half, those will match up. So let's try our last one here. -1, -3. So first we're going to fold over the y. So we're going to bring it over here. So y stays the same. The one we flip stays the same. The opposite axis coordinate changes to the opposite. Opposite of -1 is +1. So if I go over 1, down -3, if I fold on this line, they're both 1 away. And now we're going to flip over x. So we've got to bring it up now. So if we're doing x, x stays the same, -1. And then we do the opposite of -3 is 3. So here we are going to go -1, +3. When I fold this in half, those should match up. So the relationship that I noticed is that when I flip across y, y stays the same. So let's write that down. So the axis you flip over, that coordinate stays the same. So if I flip over y, the y's will stay the same. If I flip over x, the x's will stay the same. The other coordinate, goes opposite. So opposite means from positive to negative. So if it was positive, you turn it to negative. If it was negative, you turn it positive, and that will tell you that reflection line. So go ahead and complete task 1 and try those out. Again, remember, this is what the level 4 is today. So it's okay if this isn't making total sense. Just do your best here. So now it asks us, we're going to go on to some easier things. You're going to think the rest of this is a piece of cake now. So what is the distance between 2 points on the coordinate plane when we are here? So first we want to plot these. So F is not negative. It's just positive, positive. So quadrant 1 over 3 up 6. So 3 to the right, 1, 2, 3, up 6, 1, 2, 3, 4, 5, 6. So here is F. And then G is over 3, 1, 2, 3. Oh, I noticed they're on the same line. And down 2. So here is G, -2. So let's compare their x coordinates. So here's x and here's x. So I notice their x coordinates are the same. That means they're on the same line here. So let's go ahead and connect those points now to show that they are on that same line. Now see if you can figure out the distance from F to G. So go ahead and see if you can do that. So pause and come back when you think you know the distance from F to G. So I can see here, so it's count every square counts by 1. So here is, I'm going to grab a different color so I can draw over the top. 1, 2, 3, 4, 5, 6, 7, 8. So I can see there's a total distance of 8 units here. So now I want to know, what is the absolute value of F? So remember, absolute value is the distance from 0 to that point. So the distance here, hold on, lights are turning off on us. So the distance here, we're starting at 0, was 1, 2, 3, 4, 5, 6. That was its y coordinate. It went up 6. Remember, absolute value, we draw those lines around it. Now let's find the absolute value of G. 1, 2. So it's a -2 though. So the absolute value of -2 is just 2. So remember, absolute value, even if it's a negative, when we draw those absolute value lines, it means it just wants the distance to 0. Its distance to 0 takes 2 units. So 6 takes 6, 2, -2 takes 2. So are these in the same quadrant? No, this is in the first quadrant. This one is in the fourth quadrant. So they're not in the same quadrant. So how are the distance, or our total distance, if you remember, was 8. So how do you think, so here we had 6 and here we had 2. How do you think that the absolute values and the distance are related to each other? So I notice if I take the first absolute value and I add on the second absolute value, this is really like 6 plus 2. Absolute value of 6, absolute value of 2 equals total of 8. So when I take those absolute values and put them together, when they're in opposite quadrants, that gives me that total there. So before you go on and do this task 2, I have another question for you. What if F and G were in the same quadrant? So let's first figure out where they are. Over 4, up 7. So we have 4, 7. And here we have over 4. So I notice they're the same x, and then up 2. So see if you can find the distance between F and G. So I can count 1, 2, 3, 4, 5. So I think the total distance is 5. So now let's find the absolute value of F. So to get from 0 up to 7 took 7 units. The absolute value is 7. So now let's find our absolute value of G. To get from 0 to 2 took 2 units. So now my question is, when they're in the same quadrant, how is the absolute value related to the total? If they're in the same quadrant, it looks like we have to take the absolute value and subtract the other one. So we're getting rid of this extra part that has nothing in it. So we're taking that and getting rid of this extra where there's no segment. So the absolute value is 7 minus 2 equals 5. So when they're in opposite quadrants, we want to add them together because we have this and this. Put it together. But when they're in the same quadrant, they are overlapping each other, and we want to take out that part to find that total. So go ahead and try task 2 and come back when you are ready to do task 3. Okay, number 3 tells us that a wholesale chain has 2 stores as shown on the graph. Each unit represents 10 miles. So every time we cover a square, that's 10 miles, 20 miles, 30 miles, 40 miles. So we want to figure out how far apart are the stores. So yes, I noticed their map is counting in increments of 5, 10, but it's telling us every time we go 1 unit, that is 10 miles. So they just shrunk it down because to draw a full-size map of 10 miles for every unit, we would literally just have to drive to the store to read the map. So when we use maps, that's what we're doing, is we're just shrinking it down to the same scale. So they said every unit.
Mr. Daryl Anderson, if you could come to the office, Mr. Anderson, please come to the office.
So every unit is 10 miles here. So first let's find what are the ordered pairs here. So let's find A is negative. So in between 20 and 30 is negative 25. Up 5, 10, 15. So we're at negative 25, 15. Now see if you can find B. So B goes over to 30 and up 5, 10, 15. So over 30, up 15. So what do the ordered pairs have in common? They both have 15, so that means they're on the same y-axis. So we're going across following our x. So we need to look at our x to be able to see what is different here. So our absolute value of A to get from 0 to A takes 25 units. So negative 25 equals 25 units. So we're absolute value is just talking distance to get from here to here. It's like this is like Main Street. And this is on the west of Main Street. This is on the east of Main Street. So just because I cross Main Street doesn't mean I'm going negative miles. It's just saying that's the distance we have to go. So here's our distance is just 25. So now find the absolute value of B. So we have 30, which 30 units is still just 30. So we're going to use these drops here to complete this. So the absolute value of A is 25. Come on, little guy. The absolute value of B is 30. So when I do 25 plus 30, that equals 55. So we had 55 units between there. So our units, our distance was 55 units. But remember, it told us every time we have a unit, how much did the unit equal? 10. So this one unit is 10. This one unit is 10, 10, 10. And so we want to times all these 55 units by 10. And that will tell us the total distance between these two stores. So they're actually pretty far apart. So the map, right, makes it look like, oh, they're not too far apart. They're just down the street from each other. But they're actually pretty far apart. So maybe instead of Main Street, maybe this is a state line. And this is in one state and this is in another state. We can see the distance of the two, put them together, gives us our total. So go ahead and try task 3 and then complete your check for understanding and homework today. If you have any other questions, please let me know and we can set up a time to meet together.